42% of Texans carry German DNA, more than any other single European country. If that surprises you, wait until you hear what else geneticists have discovered about the Lone Star State. What if everything you think you know about Texas ancestry is completely wrong? Recent genetic studies have shattered every stereotype about typical Texans. Whether your family has been here for generations or you just moved here, this research affects how you see Texas's identity. Here's what we're uncovering today: the shocking European genetic reality that politicians never talk about, indigenous ancestry that predates every map you've seen. The complex African diaspora story goes beyond what you learned in school, and how the border moved through families instead of families moving across borders. The last revelation will completely change how you think about what makes someone authentically Texan. Because the most Texan thing of all isn't what you'd expect. We're about to take a genetic journey through Texas that's going to challenge everything you thought you knew. The German surprise, European reality check. Most people think Texas ancestry looks like cowboys and oil barons, English settlers pushed west from the original colonies. All very British, very, well, not German. But genetics tells a different story. German ancestry dominates in over 15 Texas counties. Places like Gillespie County, where 70% of residents trace their DNA to German regions. These aren't small pockets. We're talking about entire regions where German genetic markers outnumber any other European ancestry. Here's where it gets interesting. Between the 1840s and 1890s, over 100,000 German immigrants came to Texas. Not scattered individuals, but entire communities with a plan. They called it the Texas Association of German Immigration. Buy large tracts in Central Texas, establish German-speaking communities, preserve their genetic heritage. Towns like Fredericksburg weren't accidents. They were intentional German colonies designed to stay German. When communities stay isolated and marry within their group, genetic markers remain concentrated. That's exactly what happened in the Hill Country. Generation after generation maintained distinct genetic signatures that surprise genealogists today. Czech settlers did something similar around East Texas. Places like West Texas became so thoroughly Czech that locals still speak the language. Polish settlers around Panna Maria, founded in 1854, maintained Polish genetic markers for over 170 years. You can see the Polish genetic signature radiating out from the single settlement on modern heat maps. Modern genetic testing reveals patterns nobody expected. Scandinavian ancestry shows up in surprising North Texas concentrations. Norwegian and Swedish markers appear in counties where no one remembers Scandinavian immigration. The Scots-Irish story is equally surprising. Everyone assumes Texas got Scots-Irish heritage through westward migration from Appalachia. But genetic analysis shows many Texas Scots-Irish families came directly from Ireland and Scotland, bypassing the eastern United States entirely. Their genetic signatures look different from Appalachian populations because they represent separate immigration waves. Recent university studies map these European genetic clusters with unprecedented precision. The data shows Texas wasn't settled by generic European immigrants. Specific European populations targeted specific Texas regions, creating a genetic patchwork that persists today. Commercial DNA testing has made these patterns visible to families for the first time. Texans who assumed they were English or Irish discovered significant German, Czech, or Polish ancestry they never knew existed. But this European genetic complexity is nothing compared to what Spanish colonial records reveal about indigenous populations who were here first. Before any Europeans arrived, this land was home to genetically diverse populations whose impact on modern Texas DNA is far more significant than most people realize. Indigenous roots, the original Texans. Before Europeans arrived, Texas was already genetically diverse. Over 25 distinct indigenous groups, each with genetic signatures, territories, and ways of life. This wasn't empty land. This was a complex genetic landscape developing for thousands of years. Coahuiltecan peoples dominated South Texas with a genetic heritage stretching back millennia. These were sophisticated societies with established territories and genetic adaptations specific to their environment. Their DNA tells stories of Texas roots deeper than written history. East Texas belonged to the Caddo Confederacy, agricultural societies building permanent settlements. The Caddo were traders and diplomats creating a genetic legacy that shows up in modern East Texas populations. Their influence extended through trade networks, connecting them to indigenous groups across the continent. Karankawa peoples along the coast developed unique genetic adaptations. Living between the Gulf and inland prairies, they evolved traits that helped them thrive in coastal environments. Their genetic markers tell stories of people perfectly adapted to their ecological niche. Plains peoples like Comanche and Apache brought different genetic signatures through migration and conquest. The Comanche became so dominant, their genetic impact rivals any European immigrant group. They weren't passing through. They were reshaping the genetic landscape. But here's the fascinating part. Spanish colonization didn't wipe out indigenous genetics. It created something new through mestizaje. Spanish policy actively encouraged intermarriage between colonists and indigenous peoples. This was a deliberate genetic policy designed to create new societies. Tejano families emerged with complex genetic heritages, combining Spanish, indigenous, and Mexican ancestry. These families didn't just survive colonization, they became the foundation of Texas culture. The mission system played a huge role in genetic mixing. Missions were genetic melting pots, where indigenous peoples from different tribes intermarried with Spanish colonists and each other. This genetic legacy shows up clearly in modern South Texas populations. This genetic mixing varied across Texas regions. South Texas genetics look different from East Texas because different indigenous groups mixed with different European populations at different times. The genetic map reflects this complex history. Modern indigenous communities navigate complex questions about genetic identity. The Alabama Coshada maintains genetic connections to southeastern origins while showing centuries of mixing with other Texas populations. The Kickapoo preserve markers tracing to Great Lakes origins while carrying Texas-specific signatures. DNA testing complicates tribal recognition and cultural identity. Some discover indigenous ancestry their families never knew existed. Others find family stories about indigenous heritage don't match genetic profiles. Genetic identity and cultural identity aren't always aligned. Indigenous genetic heritage in Texas is more widespread than people realize. It's not just about people identifying as Native American. Indigenous markers show up in families of all backgrounds, often in unexpected combinations, with European and African ancestry. The genetic legacy of Texas indigenous peoples challenges simple narratives about belonging. These signatures predate every border, every political boundary, and every colonial claim. They represent the deepest genetic roots Texas offers. Speaking of complex identity, the African diaspora story will shock you more. The African genetic legacy goes far beyond plantation narratives most people learned in school. African diaspora, the untold complexity. Texas's African ancestry story goes far beyond slavery. Multiple migration waves, free Black communities, and genetic connections spanning continents challenge every simple narrative about African American identity in Texas. The enslaved populations brought to Texas came from diverse African regions. Genetic analysis shows West African connections to Senegal, Ghana, and Nigeria, plus significant Central African markers from regions now in the Democratic Republic of Congo and Angola. These different populations brought distinct genetic signatures appearing in different Texas regions today. East Texas shows stronger West African connections, reflecting the cotton economy. This alignment is indicative of the historical labor demands created by the plantation system, which heavily relied on enslaved individuals from specific regions of West Africa. In contrast, South Texas exhibits a richer diversity of cultural influences, including markers from Central Africa. These connections suggest different migration patterns and economic systems that may have emerged due to varying agricultural practices and the geographic positioning of these communities. The differences between East and South Texas illustrate a broader narrative of African American history in the region. In East Texas, the monoculture of cotton led to a more homogeneous cultural retention, while South Texas's agricultural variety facilitated a blending of traditions and practices. This intertwining of diverse African heritages has fostered unique cultural expressions, impacting the social and economic fabric of the area. Understanding these distinctions not only provides insight into the historical diaspora, but also enriches our appreciation for the varied cultural landscapes present in Texas today. Texas housed significant free Black populations before the Civil War. These communities had different genetic patterns than enslaved populations because they included people of mixed African, European, and indigenous ancestry who gained freedom through legal mechanisms. The post-Civil War period created new genetic patterns through internal migration. Newly freed people moved across Texas, establishing communities and creating genetic connections that hadn't existed before. This internal migration created mixing patterns completely different from the original plantation populations. The 20th century brought additional African American migration to Houston, Dallas, and San Antonio. These urban populations brought genetic diversity from across the American South, creating mixing patterns reflecting complex African American migration throughout the United States. But here's what complicates the story. Texas's border location created unique genetic connections you won't find elsewhere. Afro-Mexican populations moved across the border for centuries, creating genetic patterns, challenging simple racial categories. Colonial Spanish Texas housed free Black populations with different legal statuses than enslaved people in the United States. These communities intermarried with Mexican populations, creating signatures combining African, indigenous, Mexican, and Spanish ancestry in ways that don't fit neat categories. These Afro-Mexican connections continued long after Texas joined the United States. Families maintained cross-border relationships, creating genetic patterns reflecting border life complexity rather than simple political boundaries. Modern genetic testing reveals these patterns to families who never knew their heritage. African American families discover Mexican indigenous ancestry. Mexican American families discover African markers. The border region shows genetic mixing reflecting centuries of cultural and genetic exchange. Different African migration waves created distinct genetic clusters across Texas. Houston's African American population shows different patterns than Dallas's because different migration streams brought different genetic heritage to different cities. Recent studies reveal surprising connections between Texas African American populations and other African diaspora communities throughout the Americas. Genetic markers show connections to Caribbean, Brazilian, and other diaspora communities, reflecting complex Atlantic slave trade patterns and subsequent migration. This complexity becomes more interesting considering how it intersects with the Mexican-American genetic story. The Texas-Mexico border has always been more a genetic bridge than a barrier. Genetic patterns along the border tell stories of continuous mixing and connection, challenging simple narratives about belonging. Which brings us to the border story that changes everything. The border moved through families instead of families moving across borders. Border genetics, the moving boundary. The border crossed them, but they didn't cross the border. When the Treaty of Guadalupe Hidalgo was signed in 1848, thousands of Mexican families suddenly found themselves in the United States without moving. Their genetic story challenges every assumption about immigration and belonging. Tejano families lived in Texas for generations before it became American. These weren't recent immigrants. These were established communities with deep genetic roots in Texas soil. Their heritage combined Spanish colonial, indigenous Mexican, and often African ancestry in patterns developing for centuries. The 1848 treaty didn't just change political boundaries, it created genetic communities suddenly divided by an international border. Families that intermarried for generations were split between countries. Genetic connections developed over centuries, didn't disappear because politicians drew new lines. The Mexican Revolution of 1910 brought new genetic diversity as refugees fled violence. These weren't just opportunity seekers. These were communities carrying genetic heritage, reflecting Mexico's complex history. The genetic diversity was extraordinary. Indigenous Mexican ancestry included markers from Aztec, Maya, Zapotec, and dozens of other groups. Spanish colonial ancestry brought European markers, plus Middle Eastern and North African signatures, reflecting Spain's complex history. Some families carried Lebanese, Syrian, and Jewish markers that reached Mexico through Ottoman Empire migration. The 1930s brought tragedy through forced repatriation programs. The United States deported over 1 million people of Mexican descent, including American citizens whose families had been in Texas for generations. This scattered genetic communities and broke connections, building for decades. The Bracero program of the 1940s to 1960s created new genetic patterns as temporary workers became permanent residents. These connections reflected specific Mexican regions, creating Texas communities with genetic ties to particular Mexican states and towns. Modern migration continues adding genetic complexity. The genetic data shows continuous flow in both directions across the border for over a century. This isn't just about the Mexico to Texas movement. This is about genetic communities existing on both sides of the border. The genetic reality challenges simple political narratives. Testing reveals families with deep roots on both sides, genetic connections predating the border, and patterns reflecting complex cultural and economic relationships between Texas and Mexico. This genetic mixing created unique regional patterns. The Rio Grande Valley shows different signatures than El Paso, which differs from San Antonio. Each border region reflects a specific history of mixing and migration. Lebanese and Middle Eastern markers appear in surprising border concentrations. These reflect late 19th and early 20th century Ottoman Empire migration to Mexico, followed by secondary migration to Texas. Global migration patterns created unexpected genetic connections. Jewish markers also appear unexpectedly, reflecting both Sephardic populations fleeing to Mexico during the Spanish Inquisition and Eastern European Jewish populations migrating to Mexico in the early 20th century. The border has never been a genetic barrier. It's been a genetic bridge connecting populations across political boundaries. Border community genetic heritage reflects this reality in ways political rhetoric often ignores. Modern DNA testing reveals these connections to families who never knew their heritage. People thinking of themselves as simply Mexican Americans discover Lebanese or Jewish markers. People considering themselves simply Texans discover deep Mexican indigenous ancestry. Looking at all this genetic data, you might wonder what it means for Texas identity. The answer is more profound than you'd expect. What this means for Texas identity. Texas has never been genetically homogeneous. The political narratives dominating Texas discourse don't reflect actual genetic reality. The data shows something much more complex and interesting. Modern genetic studies reveal that average Texans carry ancestry from multiple continents. German, Mexican, African genetic signatures show up in families across the state. Indigenous European African combinations create profiles reflecting Texas's complex mixing history. Most Texans carry far more diverse ancestry than their family stories suggest. Geographic patterns make this diversity more interesting. East Texas genetics differ from West Texas. The Gulf Coast shows different patterns than the Hill Country. Each region tells its own genetic story, reflecting specific histories of migration, settlement, and intermarriage. Personal stories behind these patterns are extraordinary. Families discover German ancestry they never knew existed. Others find indigenous markers their families forgot or hid. African American families uncover Mexican connections. Mexican American families discover European or African ancestry, challenging their heritage understanding. DNA testing has made these discoveries accessible to ordinary families. Testing reveals histories hidden by adoption, migration, family silence, or time's passage. The data often surprises people, but helps them understand their place in Texas's complex tapestry. The political implications are significant. Rhetoric, assuming genetic homogeneity or defining authentic Texas identity through ancestry, doesn't match genetic reality. Data shows genetic diversity has always been the Texas norm, not the exception. This diversity challenges cultural assumptions about Texas's identity. The cowboy mythology dominating Texas culture doesn't reflect most Texans' actual genetic heritage. The German farmers, Mexican vaqueros, African-American cowboys, and indigenous peoples who built Texas culture are all represented in genetic data. This genetic mixing created something entirely new. Texas genetics don't just reflect populations that moved here. They reflect the unique mixing that happened when these populations encountered each other. Texas genetic signatures represent something that didn't exist anywhere else. Continuing genetic mixing adds a new complexity. Modern global immigration continues adding genetic diversity. Asian, Middle Eastern, and African markers join the existing mix, creating even more complex patterns. The genetic data suggests the most authentically Texan thing isn't any single ancestry. It's the incredible genetic mixing that created something new, Texas as a genetic laboratory for American diversity. Texas is a place where genetic boundaries dissolve and new combinations emerge. This offers a different way to think about Texas identity. Instead of defining Texas's identity through exclusion, determining who belongs and who doesn't, genetic data suggests Texas's identity has always been defined through inclusion, through mixing different genetic heritages to create something new. The genetic story of Texas is ultimately about American diversity itself. Texas has always been America's genetic crossroads, where different populations met, mixed, and created new genetic combinations. The genetic heritage of Texas represents America's genetic future. Remember that German statistic we started with? 42% of Texans carry German DNA. But most of those same Texans also carry Mexican, African, or indigenous ancestry, or combinations of all of these. The German ancestry is just one thread in a much more complex genetic tapestry. The most authentically Texan thing isn't any single ancestry. It's the incredible genetic mixing that created something entirely new. Texas has served as America's genetic laboratory for over 2 centuries, where different populations encountered each other and created genetic combinations that didn't exist anywhere else. Your family's story is part of this incredible tapestry. Whether you're discovering German ancestry you never knew existed, indigenous markers connecting you to original Texans, African heritage reflecting the complex diaspora story, or Mexican ancestry predating the border itself, you're part of a uniquely Texan genetic story. The genetic data shows Texas's identity has never been about genetic purity or single ancestry. It's always been about the mixing, the complexity, the beautiful chaos of different peoples, creating something new. That's the real Texas story. What surprised you most about your own family's genetic story? Have you discovered ancestry that challenged your family's traditional stories? Share your discoveries in the comments below. Next week, we're diving into how Texas's genetics compare to California's genetic diversity. You won't believe what we found. If this changed how you see Texas, you'll love what we uncover next. Hit that subscribe button and ring the notification bell.